and all I typed in was derivative properties and laws. So I would highly suggest getting one of these cheat sheets. Y'all finished?
Yes.
Okay. Can I be in charge?
If you want.
Okay. All right. Get this cheat sheet and keep it with you, because you're not going to remember everything. I mean, it's nice to remember everything, but it's going to be hard.
Can you
Okay?
print it?
Yeah, when you put it in, when you download it, yeah, you can print it. I think you should be able to.
Is it online?
I just said it was on Google. That might have been when you were talking.
That's probably what it was.
Okay. All right. Now, as far as derivatives go, I've already talked to you about derivatives, but I've looked through the chapter, and a lot of the problems are going to be kind of a business-based type. So they're going to be dealing with a lot of exponents and a lot of natural logs. So you're going to have to really focus on the natural log and the exponent, which I don't know if it's on here, but if it is, we'll find it. You don't have to worry too much about. You have to worry about these two, because they do introduce that in the latter part of the chapter. The chain rule, we'll go over the chain rule. Not all of those chain rules, but we'll go over the chain rule. We'll go over the product rule, the quotient rule, which we've already covered, but we'll go over it again. The power rule, we've already discussed that. We've done these three. There's the chain rule. There's the basic chain rule. We'll go over that. I don't see the natural log. Yeah, there it is. The derivative of the natural log, the derivative of e of x. Okay, here we go. These right here. Those are important. And that's basically what chapter 3 is on, those areas right there. And what we're going to do today and Thursday is just do nothing but problem after problem after problem. Okay? Now, again, a lot of your algebra skills are going to be used here. And I think I've reviewed that enough. We're also going to be talking about the inflection rules, the derivative, the second derivative. We're going to be talking about that. I'm going to get you to graph some on your calculator so you can see what the graph is doing. But as far as compared to 140, it's not going to be as difficult, because you're not going to be going into the more nested problems. Y'all know what nested problems are? When you have derivatives inside of derivatives inside of derivatives. In other words, you have 2 or 3 problems in one problem. So we're not going to be getting into that too much. So it's kind of like just hitting the surface with these problems and not going into depth too much. Now, you're going to be going into depth with the business type models. But anyway, we'll go ahead and get started. I'm going to just go over a few things that we've already been over, because I thought we were going over it in Unit 2, but we wasn't. So I'll just go back over what I was talking about in about 2 or 3 weeks ago. You've got the power rule, which is basically if you have a to the n power, then that's going to yield n times a to the n minus 1 power. Then you have the product rule. And the product rule basically says first times the derivative of the second plus the second times the derivative of the first. And you might want to write that out so you don't have to ask me when you see it again what the F means and what the S means. The quotient rule is denominator times the numerator prime minus the numerator times the denominator prime. over the denominator squared. The chain rule, I'm going to wait on the chain rule. I'm not going to write the chain rule down because if I wrote it down, it would confuse you. The best way to show the chain rule is to just do the problems. Okay? I don't write the chain rule down. If you'll look in any of your books, the way that they write the chain rule, it confuses you before you even start. So I don't write the chain rule down. Don't forget that the natural log, the derivative of, I guess, d of x, I'm going to write it like that, dy dx, d of x, the natural log of x is equal to 1 over x. The derivative of e to the x. Now, nobody should get this one wrong. If you get this one wrong, you don't even whisper it to anybody. What's the derivative of e to the x? Anybody?
E to the x.
E to the x. So please don't screw that up. All right? And of course, there's several other natural log rules over there on the sheet. I'm not going to deal with those right now. I just want to cover these, and I want to add the chain rule. I'm going to put the chain rule right here, and this is what we're going to cover the next 2 days. We're going to cover these right here. Now, when I say we're going to cover these, we're going to cover them as far as the mechanics, how to do them, what they mean, and what they mean in a business aspect. Okay, because in a business aspect and a engineering aspect, they mean two different things. In an engineering aspect, the first and second derivative means the speed and the velocity, and in the slope and the velocity. And in a business aspect, it means the slope, but it also means the rate of change, and it also means inflection points, where you see a transition of the curve. And that kind of helps us because it's kind of hard to see the transition of the curve. All right, so let's throw some examples on the board and let's see, if everybody can remember their derivatives. All right, so first we'll start off real simple, negative 2 x to the 5th power, and I'll just f of x is equal to, and then we'll go with f of x is equal to 1/4. This battery must be going. Let me use the other one. That one's doing too many dots. Yeah, those that asked about the field trip, I'll just tell you, we went to Atlanta. We had 2 tour buses. It was real nice. I mean, it wasn't like your old field trips that some of y'all took, or some of the ones that I took in the orange buses, and everybody burned up and was uncomfortable. And no, it wasn't nothing like that. We had 2 tour buses, one for the girls, one for the boys. We went to the zoo in Atlanta. We went to the aquarium, Coke World, and CNN. I didn't go into CNN. I stayed outside. But after that, we went to the Legoland, and they didn't like that too much. But I dropped my phone at the zoo. Now, I'm not talking, I didn't drop it like from my hands down. I dropped it over a ledge of like a handicap ramp. So it went down about 10 feet and hit concrete. So it cracked. And I said, okay, no big deal. It continued to work. Then I dropped it a second time. Then at Coke World, I dropped it a third time.
Good.
And then the aquarium finished it off. And I dropped it on that hard aquarium floor, and the whole screen turned purple. But I did call it in after I dropped it the first time when it cracked. I went ahead and called it in, and there was one waiting on me on my front porch when I got home. So I had to transfer everything over, and I'm still transferring stuff over. It's making weird noises, and I don't know what they mean. But anyway, and then I told my mother, to go get my truck because I didn't want it sitting out there in the parking lot because it had tools in the back of it, and I don't want them stolen. So I told my mother to go up to the school, because the school is only a half mile from where we live, and tell her to take my truck to my house and park it in the front where people see it. And she backed into one of the teacher's cars. She's 78 years old, and she drives the truck all the time on the farm, but she's about this tall.
You put her in the doorway.
Well, she don't mind. She drives it all the time on the farm, but she just, and she didn't even know it. All right, this is the fun part. She didn't even know that she hit somebody's car. She backed into it with the bumper, and the bumper's like caved in the whole back end of the car. All right, didn't even scratch the truck. So I get a call yesterday about 2 o'clock, and it was the principal, and the principal went with us down to the, and she said, Hubert, you've had a wreck at the parking lot, and you wasn't even here. I said, oh, Lord, what happened? And as soon as she said that, I knew what happened. And she said, we just got through looking at this film, and somebody came and got your truck and backed into one of our teachers. I said, that was my mom. She said, you need to see the film? I said, no, I'll trust you. So I had to call the insurance company yesterday. So that was how my field trip went. I know, it's female drivers. That's what it is. But she usually drives it pretty good. But anyway, I thought it was funny. All right. F of x is equal to 1/4 x to the, or negative 1/4 x to the negative 4th power. And f of x is equal to 1 over x to the negative 3rd power. Okay? Now, of course, most of y'all can do that first one without even doing anything. But the second and third one may cause you a little bit of problems because you can't remember some of the rules. Okay? And that's what happens in calculus. I asked y'all before at the first week of class who had calculus and who didn't. There was some of y'all that's taken this class over, some of you that hadn't had 130 in a while, or 109 in a while, or whatever class before this one. Some of you have taken engineering calculus. The whole point is this stuff does get rusty. And if it gets rusty, you make mistakes. So, first of all, I'm going to bring this out, and that gives us a negative 10 x to the 4th. And like I said, most of y'all get that right without a problem. The second one, I'm going to write it out. Now, I'm going to write it out because y'all suck at fractions. And that's just normal for students. Okay? So I'm going to write it out. I'm going to bring the negative 4, that'd be a negative 4 over 1, times negative what? 1/4. And x to the negative 4 minus what? 1. We always minus 1. Now, the reason I'm writing it out, there's two things y'all going to screw up on this. Are y'all listening? There's two things that students screw up on this. Name the two things. Go ahead, y'all might as well say it. Y'all know what y'all screw up on. What do they screw up on, this problem? What do students screw up on?
The exponent.
The exponent? What else?
Distributing the fraction up front.
They do the fraction out front, and they don't know how to do fractions, and then they screw up the sign out front. 3 things. And let me tell you, out of 10 students, 3 to 4 mess this up. So don't mess it up. Write it out. So you get x to the what? Negative 5th. Now, when you look at negative 1/4 x to the negative 4th, you wouldn't think that you'd get x to the negative 5th. So, again, be careful.
What rule do you use for that?
That's the power rule. Same thing we used right here.
Just making sure.
I'm sorry, what?
And then 1 over x to the 5th. No.
The answer is x to the negative 5th. Yeah, I'm sorry. And then that would be 1 over x to the 5th, and you could write it either or. But yes, this is the correct way. Thank you. I forgot.
I
Sorry.
forgot how to do that.
Yep. But you can't get it wrong I mean, the only thing I can do right here is just say 1 over x. I can't mark this wrong. Mathematically, it's not wrong. All right? But that's the thing. That's the kind of stuff that gets you on these problems. Now, what about the chain rule and the product rule and the quotient rule? If you made an error on that one, that problem we just did, does that mean you're going to make an error on the chain rule, the product rule, and the quotient rule? Yes. So therefore, now you've got 4 things that you're going to mess up on. So you got to make sure you understand how to manipulate these problems. This problem. First thing I'm going to do is I'm going to rewrite it and get what? X to the third. Now I'm going to use the power rule. 3x what?
2.
Now what do students do here? They just stare at it. I'm telling the truth. They forget that the exponential rule says, the inverse rule says that you can invert that and make it x to the third over 1. And they forget it. They just stare at it. All right, question on those. Now, what do? Well, this is the point. If you was to graph this, I want everybody to take your graphing calculators out. I want you to graph it. Now I want you to graph this. I want you to graph this. And then I want you to graph this. I mean, you don't have to do it all at one time. I just want you to do it, between now and next time we have class. And then graph this versus this. Now this one's the one I really want you to graph, because this one you may see some application in. This one right here. Because you've got an x cubed. Now what does the x cubed do? The x cubic function has an ending behavior that looks like what? Looks like that, right? And what does the parabola have? It has an ending behavior that looks like that. This is where you're going to see your inflection points. The first derivative is the slope. The second derivative, what is the second derivative? 6 what? 6x. And you can find your inflection points with the 6x. Okay? Just a little bit of where we're going with that. All right? So let's try next the product rule. Product rule is next. Now, I'm going to use the product rule in a basic form, just so to give y'all a little bit of knocking the cobwebs loose. So we're going to do 2x to the negative 4th power. F of x is equal to x to the negative 4th power. Now, you can use the power rule, but that's not what I'm telling you to use. I want you to use the product rule. Got a first term, and you've got a what? Got a second term. First times the derivative of the second plus the second times the derivative of the first. So I want you to go through, and I want you to actually put those things in there. Now, what is this accomplishing? Well, to those that have not had calculus in a while, it is knocking the cobwebs loose. And those of you who have not had calculus, you need to learn this property. And those of you that invented calculus, I don't know why you're in here in the first place. All right. So, that's you trying to be a businessman or something, drinking a coffee? What are you bringing a coffee cup to class for?
He's thirsty.
Thank you. Thank you.
Whatever.
Yeah, you're welcome.
Hey, at least I didn't drop my phone 4 times.
Shut up. First times derivative of the second. Negative 4x to the what? Negative 5th. And I'm going to put that in parentheses to show that I took that derivative. Plus the second to x to the negative 4th times the second, or the first derivative first, which is 0. I'll do this one for you. That goes to 0. And your derivative is negative 8x to the negative 5th. And of course you can rewrite that. Now I'm not really concerned about that. But now you can go up here and you can do the power rule and check it. Negative 4 times 2 is negative 8. X to the negative 5, 4 minus 1, which is equal to negative 8, x to the negative 5th. But that's how you use the power rule. Now, when will you use the power rule? Well, you can use the power rule with, okay, you can use it with this. F of x is equal to 4 natural log of x. Do that one. Now, there's 3 people in here. There's the person that's never seen calculus before, and they're saying, "Whoa, wait a minute, what are you doing?" Okay, just chill, all right? Because we're going to go over more and more problems. There's a person who hadn't had calculus in a while, or had calculus and can't remember it, and you're going, "Oh yeah, I remember how to do that. That's good." And then there's a person that knows how to do it, and you just keep them out. All right. So first times the derivative of the second, plus the second times the derivative of the first, you get 4 over x. Now, let me ask y'all something. Do y'all remember in algebra? Y'all remember in 109, I taught some of y'all, and I told y'all, and some of y'all have had me for algebra. When we got to the shortcuts, I told you in completing the square, I told you that you had to be fluent with the shortcuts, and you had to be fluent with completing the square. Derivatives, you have to be fluent. You have to be able to take the derivative of a problem and just be able to do it just like that. If you're sitting there and going, "Okay, wait a minute, I need to go back to my cheat sheet," then you're going to suck at antiderivatives. Okay? And if you suck at algebra, you're going to suck at derivatives. If you suck at derivatives, you're going to suck at antiderivatives. If you suck at derivatives, if you suck at algebra, antiderivatives, and derivatives, you're going to flunk the class. All right? So the things that I'm telling you have to get good at, you better get good at. And taking a derivative, you're not supposed to be. Now, some of y'all that are remembering, and some of y'all that's never had it, you have that excuse. But at the end of this unit, you better be able to take the derivatives without hesitation. It should be fluent. It should be like second nature. All right? Let's try another one. F of x is equal to x plus 2 times 3x minus 4. There's 2 ways to do this problem. I want you to do it both ways. If you can't do it, just write it up as what? Failure. Write it up as what? Yeah, you're a failure. All right, 2 different. I want you to do it both ways. And everybody in here should be able to do it both ways because there's nothing new. I haven't shown you anything new on this problem. Product rule or the other way. All right, somebody say which way you could do it besides the product rule.
FOIL.
I'm sorry, what?
FOIL.
FOIL. Yes, not shortcut, but FOIL. I think you were thinking the right thing. In other words, your algebra. First, outer, inner, last. Or if you're not from around here, first, outside, inside, and last. All right? The other way is to do the product rule. So you have your choice. I'm going to do it both ways. Now, if you use the FOIL method, then you're going to have to revert to the sum and difference rule of derivatives. Now, I didn't cover that because that's pretty self-explanatory. I'll show you why. The sum and difference rule says if you have A plus B, you can take the derivative of A and you can take the derivative of B and add them together, which that's not a big rule, okay? So, f of x can be rewritten using the FOIL method as 3x squared minus 4x plus 6x minus 8. And that can be rewritten as 3x squared plus what? 2x minus 8. And that's f of x. Now, if I wanted to take the derivative, that would be f prime of x, or y prime, or d dx. However, I don't care how you want to write it. And that would be 6x plus what? So that's one way to do it. Another way to do it is first times the derivative of the second. What's the derivative of 3x? 3, Hubert. Plus the second times the derivative of the what? First. 3x plus 6 plus 3x minus 4. What's 3x plus 3x? What's 6 minus 4? Lord, it's a miracle. What movie does that come from? Shawshank Redemption. Shawshank. I can't pronounce that real good. Shawshank. The prison movie.
Shawshank Redemption?
Yes. When the warden says, Lord, it's a miracle. Man up and vanishes like a fart in the wind. You know, when he tunnels through the wall? Whatever, y'all ain't never watched it. Classic movie and y'all ain't never watched it. And it's got Transformers or comic book characters in it, so y'all don't watch it.
Is Morgan Freeman's next door?
Is it supposed to match? Yes. If you get two different answers, then you suck. Y'all notice what's in both of them? What's in both of them? Starts with an A.
Oh, you just do the everything.
L, G, algebra. If you suck at algebra, you're going to suck at calculus. Now, is this the hardest problems y'all are going to do? No. So we're going to get into algebra a whole lot more. Anybody got a question about the product rule? All right, let's go to the quotient rule. Quotient rule says denominator times numerator prime minus the numerator times the denominator prime over denominator squared. And that's the quotient rule. So, we'll take something really simple and run through it. Now, is it important that you add these these parentheses, yes or no?
Yes.
Why? Anybody want to take a guess? How's that guy? If you don't remember to distribute that negative, you might as well just what? Quit, because you're going to get the problem wrong. You've got to remember to distribute that negative not only across one, but across what? Two terms. And that's where most students, the 10 students, 3 that get it wrong, that's where they get it wrong. So let's go with something simple. Let's go with 4x squared over, I'm just going to make this up, and I know you can reduce it, but just go with me, okay? 3x to the negative 4. So f of x, I know you can cancel it, but we're just starting We're crawling before we can walk, because I don't know how many people remember the quotient rule, and I don't know how many have never seen it. Let's go ahead and do it. Give you a minute or two to start on it. And go ahead and work on it the second way. Do algebra first and work on it the second way. Okay, so denominator times numerator prime minus the numerator minus the denominator prime. Y'all check me. Over the denominator squared. Now, is there multiple places for y'all to screw this up?
Yes. Yes.
Yes. Can anybody name any?
Not distribute.
I'm sorry, what?
Not distribute.
Not distribute the negative. Like I said, yes, that's the first place. Where else?
Wait, why did you put a negative, like a negative? 12x in there.
Okay, take the derivative of the denominator.
I know, but shouldn't it be times 4x squared times negative 12?
Okay, thank you. Yeah, you're right. Thank you. I was thinking of this negative right here. Sorry, you're right. Should be times. Besides writing the problem down wrong, like I did, I was thinking of this negative right here, and I wrote it twice. There we go. But this is the first place that you will make an error because you don't distribute that negative. Where is the second place that you can make an error?
Negative 4 and denominator.
I'm sorry, what?
The x to negative 4.
Yes, right in here?
Yes.
Yes. I think what you're talking about is squaring not only the 4, but you also have to square the what? 3. That would be the next error. Another error would be right here. People forget to make that negative 4 times 3 of what? 12. A negative 12, and you just put 12. There are all kinds of places in here where you can make these little errors. That's why you need to make sure these first 2 or 3 sections that we go over in chapter 3 that you've got an 8 out of 10 as far as knowing how to do this stuff. Because it's going to come back and bite you in the rear later on when we do antiderivatives. All right. So, 3 times 8?
24.
24. X to the negative 4th times x to the 1st is x to the what?
Negative 30.
Negative 3. Using your product rule of exponents. Minus, and I'm just going to deal with the inside parentheses first. 4 times negative 12 is negative what?
48.
48. X to the 2 minus 5 is negative what?
3.
3. Over, and that's going to be 3 to the 2nd is 9, and x to the what? Negative 8. All right, now do the next step. If you haven't done it yet, do the next step. Another thing that's very important with these problems is that you do every single step. Now, guys, y'all don't like to do this. Okay, males do not like to write every other step. They don't like to follow directions, and they don't like to write out steps. They want to do everything in one step, and they're the ones that get the most problems wrong. Write out every step. How do you know when you don't need to write out every step? Well, when you get 10 out of 10 problems right, and you're not writing out every step, then you can do that. Okay? If you get 7 out of 10 problems wrong, then something's broke. And you're skipping steps and you need to write them out. I'm going to remember that when you ask me a question, and I'm going to start texting on my phone.
Your broken phone?
My phone ain't broken no more. If I want anything out of you, I'll ask you. All right. So, whoever said that. 24 x to the negative third. And what do I do with that negative? It's going to be a positive 48 x to the negative 3 over 9x to the negative 8. Well, look, we've got common terms at the top. 24 boxes of cereal plus 48 boxes of cereal. So that means we're going to have
72 boxes of
Thank
cereal.
you. 72x to the negative 3 over 9x to the negative 8.
Viewer, can you scroll it down for us?
I don't think I can. Hold on.
No, wait. No, we can scroll it down. Never mind.
Okay. That's one thing we're checking on. We're checking on if Camtasia does more. There's more screen than y'all got this whiteboard, right? The whiteboard's only taking up like 3/4 of the screen, right? On y'all's screens at Easley and Pendleton.
Yeah.
Yeah, we're checking in to see how to make this whiteboard bigger on your television sets or whatever you call them, screens or whatever. So we're checking on that. So that's our next step, is to get better software in here, because Polycom is Skype is good, but I think it can be better. What's 72 divided by 9?
8.
8. And what's negative 3? Be careful here. You've got to use the quotient rule of exponents, so you've got to subtract. That's going to be negative 3 minus a negative 8, which is negative 3 plus 8, which is
5.
5. So your derivative of 4x squared over 3x to the negative 4th should be 8x to the 5th. Now let's check it using algebra first. And I'm just going to put 4 over 3 times x to the 2nd over x to the negative 4th. And that's going to be 4 over 3 times x to the 2nd times x to the 4th using the inverse rule. And that's going to be 4x to the 6th over 3. And that's going to be 24x to the what? 5th? 24x to the 5th over 3, which is 8x to the 5th. And you feel good about yourself. Now again, here, I used algebra. Then I used calc. Here, I used calc. And then I used algebra. The two go together. You're not going to be able to separate the two. All right? Now, let me go back to the first part of the class when we talked about there we go. I'm going to write these down for you in case you can't see it. If you have f of x is equal to a to the x power, then f prime of x is going to be equal to a to the x times the natural log of a. Right, write that down. That's when you're taking the derivative of an exponential. An exponential is like f of x is equal to 2 to the x. Now, a lot of people say, oh, I know how to take that. No, this is not what you're thinking of. Of an exponential, what you're thinking of is f of x is equal to x squared. Okay, that's what most people think of when they think of an exponential. This is an exponential variable. An exponential variable is a business type application. Exponentials and logarithms. You're going to see a lot of those because they're naturally increasing or naturally decreasing. So that would be f prime of x would be 2 to the x times the natural log of 2. So you need to get fluent at doing that. Now, e to the x and a to the x seems to be simple, but what happens if I do this? What happens if I add that? Then you've got a different problem altogether. What if I put a negative 2x on e to the x? You've got a totally different problem. Okay, there's different things I can do to make your life miserable on a test. Okay, and I don't mean that from a master of the universe part. What I mean it by is you can't just say, oh, I know how to do that. All right? When you do derivatives, it's kind of like, okay, let me put it to you like this. When you build a house, what's the first and most important thing about building a house?
Foundation.
The foundation. You got to make sure that your footing is 100% concrete, 100% metal, 100% 16 inches of concrete. You got to make sure it's solid. All right? Then what? Then you have to put what's called the I don't know what you call it because I'm not a builder, but the actual brick that go from the footing up to your floor. The skirting or whatever, it needs to be solid. It needs to be level. Okay? Right now, you're doing the skirting because your algebra is your footing. There's your footing, your concrete footing. This is the algebra. Okay? Now you're doing the skirting. That's the derivatives. And next, you're going to be putting the floor joists in. All of them, 2x8s or the 2x10s. And that's your antiderivatives. Okay, so you're not going to be able to pull these apart. You're going to have to be fluent at this, you're going to have to be fluent at this, and you're going to have to be fluent at this. If you're not fluent with each one, then you're going to suck. And if I give you f of x is equal to e to the x, and then I say, well, I'm not going to do that on the test. I'm going to give you e to the negative 3x. Then you've got to know what to do, because the answer is not e to the 3x. Okay? I told you that the derivative of e to the x is e to the x. But e to the negative 3x is not e to the negative 3x. That's why you have to know your stuff. Same thing here. You have to know your stuff. You have to know what to do if that's a negative 2. And we'll talk about that later when we get into, more problems. All right? So, what else? Well, then you got this one. E to the x, we talked about that. The f of x is equal to e to the x. The derivative, f prime of x, is equal to e to the negative, e to the x, sorry. All right? Now, if it is negative 2 or negative 3, then you have to use what we call the chain rule. And I haven't gotten there yet, so I'm not going to use it. All right? Until we get there. I don't want to get the cart before the what? You never get the cart before the what?
Wheel. Or horse.
The horse.
Something. Yeah.
If you don't know, if you don't have any idea what I'm talking about, whose fault
I
is
was
it?
thinking shopping carts. So
It's your parents' fault. You don't get the cart before the horse. And you don't teach the chain rule before you've taught the chain rule. So I'm not going to teach it yet. All right, look at this one. The natural log of x. F of x is equal to the natural log of x. The derivative is equal to 1 over x. So if you have 4 natural log of x, then you have to incorporate that 4 in there. Capiche? What happened to Pendleton?
What do you mean?
Okay. Sorry. Your camera switched to your, I thought that was our screen. I'm sorry. I thought something happened to Pendleton. All right. The next one is log base A of x. If you have f of x is equal to log base A of x, then f prime of x is going to be equal to 1 over natural log of A. 1 over x natural log of A. So, erase this stuff that I put in here. And you've got your logs, you've got your derivative laws that you're going to see a lot of in chapter 3. These 4 right here, you're going to see a lot of when we get into 3.3, 3.4, and 3.5. Because these are all business-based. So we're going to do a lot of these Thursday. So we'll go ahead and get into a few of them. Because I've already covered, chain rule. I need to cover the chain rule. So, the chain rule is the next rule. And that's the one that I don't write down because if you look at it, it's very confusing. So, I'm just going to show you how to do it. The chain rule, does anybody remember anything unique about the chain rule? Some of you people that have had calculus before or had, what do you remember about the chain rule? When I say chain rule, I don't care if it's good or bad. What do you remember about that word, chain rule? Okay, y'all remember absolutely nothing.
I remember having one test, and it was literally like I had no idea what it was.
Yeah, that's what usually, the way that they write it in the book and the way that they show it, it blows students away. It lobotomizes students because students have no idea what it's saying. And then when you get a teacher that derives it on top of that, then you're pretty much, you can't get out of a wet paper sack as far as understanding it. So, the chain rule says, that the main thing about the chain rule is that you have to take the derivative. But you have to remember to also take the derivative. Anybody know what I'm fixing to say? You also have to take the derivative of blank blank. What's inside? Does that bring back any memories? Mm-hmm. You have to take the derivative of what's inside. So I'm going to give you a real simple problem, and let's see if you can do it.
Wait, is there like an equation for it?
Yeah, but I don't write it down.
Okay.
F of x is equal to 2 times x minus 3. Nah. 2 times 3x squared minus 6 raised to the second power. Now, I want you to see how fluent your calculus is. Again, I'm talking to the ones that have had it before or think they know it. Go ahead and take the derivative of that. I don't want you to use any algebra now. I want you to use nothing but calculus, the chain rule. Now, chances are you're sitting there just staring at it. Okay? I'm talking to the students that have had calculus or the ones that think they know it. Usually what happens is the chain rule is the first one to go. because you didn't understand it to begin with. All right? When you're doing the chain rule, you take the derivative using the power rule here, and then you take the derivative of what's inside. So, here we go. This is the power rule. This is just like 2x to the second power. 2, that'd be 4x, 2 minus 1 is 1. Okay, so we're going to go back. That's what we did back at the first. So I'm going to use that same knowledge here, and I'm going to go 2 times 2, that's 4. I'm going to rewrite this, not touch it. 2 minus 1 is 1. Everybody see that? I just used the power rule. Now I got to take the derivative of what? What's inside. And the derivative of what's inside, I'm going to put it in brackets, is 6x. Now I use my algebra or whatever to finish it. So go ahead and finish it using your algebra. You would be surprised on when I show the chain rule how many people go, well, that's easy. It is easy. But if you look at the explanation, you'll be lobotomized before you even start. I never knew how to do the chain rule until somebody explained it to me, because I was looking at that dadgum mess that they defined the chain rule as. Some of y'all know what I'm talking about, but you're not going to interact with me, so I just sit here and talk to myself.
I think they give you the equation on the test just so you will try to use it.
Yeah.
Because he used to give us a piece of paper with it on it.
Yeah.
And he says, I'm giving you the equation.
Yeah, I'm giving you a chain rule.
Yeah, it should be easy.
All right. And you still have no idea what's going on. 6x times 4 is what? 24x.
4x.
What? I'm sorry. Squared minus 6. And now, since that's to the first power, now if it was to the second power, you'd have to use a shortcut. If it was to the third power, you'd have to expand it. But chances are you would stop there. But since this is to the first power, you can take it further. I'll take either answer. 24 times 3, somebody 72?
Yes.
X to the third minus 84x. Somebody check me. Now let's check it with the algebra. Now, the reason I'm checking it with the algebra is not to piss y'all off. It's not to make y'all work more. I'm trying trying to get those algebra and trying to get those.
Hubert, it's 144, not
Okay.
84.
Okay, thank you.
Yeah.
One what?
44, 12 times 12, so 6
Okay,
times
thank you.
4.
144.
Same thing.
There you go. All right, now, we would have found that error anyway because we're fixing to do it by algebra. So go ahead and do it by algebra first. You're going to have to use a shortcut. We don't need a calculator, so y'all shouldn't be playing on your phones. Unless y'all just being rude and non-courteous. Which one is it? Oh, I wasn't supposed to see y'all do that. I'm sorry. All right, so let's do the algebra. Remember I said, if y'all need to use the phone, if it's that big of a deal, then what do? Go outside and use it. All right, so 2 times, well, that's shortcut number what? Number 2, Hubert. That's right, class. So that's going to be 9x to the 4th minus 3 times 6 is 18. That'll be 18 is 36. 36x squared. Y'all check me. Oops, that's wrong. 36x squared minus or plus 36. Again, check me. And that's going to be 2 times 9 is 18. 18x to the 4th. 18x to the 4th minus 72x squared plus 72. And if you take the derivative of that, that 72 is going to fall off. And 4 times 8, 72. X to the 3rd minus 144x. It's amazing. Is it a bad thing to do these problems the two different ways? No, it is not. But if you want to suck at calculus, then you might want to do the lazy route, which means just do it one way. If anybody in here has played a musical instrument before, this is the closest thing. Doing calculus with the algebra, the derivatives, and antiderivatives is about the closest thing in mathematics to playing a mathematical instrument. If you suck at it, it's going to sound terrible. If you don't practice a lot, it's going to sound terrible. It's not going to come out good. All right, now let's do the chain rule with the other function that I was going to do it with. F of x is equal to e to the negative 5x. Now, the reason you have to use the chain rule here is e is its own unique thing, just like the natural log is unique. You have to treat it like another term. And the negative 5x is also another term. So you have to do the following. You have to say, okay, the derivative of e to the x is e to the x, right? So that would be e to the negative 5x. But what is the derivative of negative 5x? I'm asking y'all. That's not rhetorical. I'm asking y'all to give me some interaction. What is the derivative of negative 5x?
Negative 5.
Negative 5. So you got to multiply by what's inside. So the derivative of e to the negative 5x is equal to what? Negative 5 e to the what?
Negative 5.
Now you see how this stuff can get you. Because some of you would have put, oh, well, the derivative of e to the x is e to the x, so the derivative of e to the negative 5x is e to the negative 5x. And you would get it wrong. Another one. Let me show you a very, very common problem that students get wrong. Now, a while ago, and you don't have to worry about this as much in calculus and business calculus, but the reason I'm showing you, there's a reason I'm showing it to you. Just hold on. Where's the stupid? There it is. Okay, the derivative of sine is cosine. Derivative of cosine is negative sine. All right? But let's go and do the sine. Let me do the sine. F of x is equal to sine of 4x. Now I just told you the derivative of the sine is cosine, derivative of cosine is a negative sine. That's how you need to remember that. Because if you remember it like that, that's about the only way you can remember it. Because when you get to the antiderivative, it's totally opposite, and you're going to get really screwed up because they're so similar, but they're totally opposite. So you better go ahead and memorize that one now. Derivative of sine is cosine, derivative of cosine is a negative sine. All right, what's the answer here? Well, the derivative of sine is cosine, so it's going to be cosine of 4x. Right or wrong? Wrong. See, another hiccup. I thought it was a cosine. Yeah, it is. When this is a what? Sine of x. When this is a 1, the derivative of sine is cosine. Because the 1, by the chain rule, is the multiplicative identity, which doesn't change this right here. Well, what happens when you have a 4 here? Chain rule. 1 is the multiplicative identity. So 1 you don't have to mess with. Do you remember distributing a 1 across parentheses to get rid of the parentheses? No, you don't have to do that because 1 is the multiplicative identity. So there's a lot of things you can get away with without having to do the 1. If this number is above 1, you've got to use the chain rule. So what is the derivative of the sine of 4x? The cosine of 4x, and then you take the derivative of what's inside. This is what's inside. What's the derivative of 4x? So your answer is 4 cosine 4x. Do you now see why students suck at calculus? They suck at calculus because they just know enough about calculus to get themselves in what? In trouble. You've got to be fluent. You've got to know these first laws like the back of your hand. If you don't, C or less. Okay? And usually it's not a C. And you can do the same thing with the natural log. Here we go. Natural log. F of x is equal to 4 natural log. No. Let's see. Natural log of 2. I don't want to do 2x. Hold on a second. Yeah. Natural log of 4x. Now, you can pull that constant out. That 4, you can pull it out and not even worry about it. But the natural log of 4x is not what you think it is, or 1 over 4x. All right? Well, it is. No, it's not. Because you have to take 1 over x. The natural log of 4x is going to be 1 over 4x. So that's going to be 4 times the natural log of 4x is 1 over 4x. And then you have to take the chain rule, 4x is 4, and then 16 over 4x, which is equal to 4 over what? Now that one came out to be nice, what you thought it would be, but you've got to be careful with natural log of x. Natural log will get you in trouble more than e to the x will get you in trouble. And what we're going to do Thursday is nothing but problems. I'm going to have, now get ready for Thursday because I'm going to have nothing but problems. I'm going to have the problems that are easy, and I'm going to have the problems that's going to stump you. Okay, so, and the ones that have the hiccups in them. So what I want everybody to do tonight is I'm not going to assign homework tonight because I haven't put all this together. This is what I'm going to do. The first is chapter 3, right? Is this chapter 3? Okay, the first thing I'm going to do is I'm going to establish the laws. Okay, I've just done that today. I've established the laws. The second thing I'm going to do is we're going to get all the hiccups out of the... Now, what are the hiccups? The hiccups is where y'all screw up. Okay, that's what we're going to do Thursday. And then we're going to apply models. Now, where are we right now? We're 3.1... 3.3, 3.4. We're 3.1 through, I think, 3.4, 3.3 or 3.4. But I haven't done this. Okay, so that's why I'm not going to give you any homework yet. And plus, you've still got the test to worry about. So just consider this a test, a class day. But that's where we're heading Thursday. We're going to work problems. And then here is Tuesday, I'm going to apply the models. Okay? All right, y'all get out of here. If you got any questions for me, stay over. Make sure you don't drop your phone 4 times.